Hey, welcome back. This is Samaya Madhavan, and in this next set of videos, I'll be walking you guys through the introduction to convolutional neural networks. At the end of the series, I'm hoping you guys will be comfortable and confident about the internals and implementation of image processing using CNN. Let's get started. So, for you guys to be able to understand the different steps that goes into building a convolutional neural network, there are a few preliminary understanding that needs to happen. So in order to do that, I'm going to begin by giving a very high overview of what deep learning is and where it fits, and then moving on to understand what artificial neural network is, again on a very high level note, because artificial neural networks is what lays the foundation to CNN. And then we'll move on to learn about what CNN is and where it fits within the deep learning realm. And after that, we'll go into each of the steps that actually go into building a convolutional neural network architecture, which is image channel, convolution, pooling, flattening, and full connection. As far as this video pertains, we'll be talking about introduction to deep learning, artificial neural networks, and introduction to convolutional neural networks. That said,
Deep learning for some reason is misconstrued to be a technology or a set of architecture that's in competition to machine learning, but in reality it's not. Deep learning is a set of architecture that gains its power, and the reason why it's more popular today is because of the availability of abundance of data, which we've never had in the past. And the second big reason is the availability of the underlying processing techniques, like the advancements in GPUs or TPU, which is tensor processing units. They all enable us to have faster training time for these models, which otherwise would take weeks and weeks to train, which is in all practicality not possible. So any problem that is solvable by machine learning is solvable by deep learning. And as you see in the picture, machine learning falls under or is one of the subsets of artificial intelligence. That said, let's move on to understand a little bit about what artificial neural network is. And in this video, we are not going to, go into a lot of details of artificial neural network. I intend to make another series, if you guys would like, on ANN. But for the sake of understanding CNNs, there is definitely some amount of understanding that needs to happen with ANN. ANN, or artificial neural networks, as the name indicates, is inspired by how a human neural network actually works. So, for example, if we have an apple and our brain tries to understand how to identify that we have an apple presented to us. You can imagine that you look at an apple and you see that it's probably round, it's red in color, and then you probably touch it and you see that it's a little firm. So all these three characters put together, your brain internally tries to make some processing to understand that it's apple, and then you come back and tell the person that questioned you, and you're like, it's an apple, and then the person that presented you with this problem says, hey, you're right, you don't have any errors, right? But what if you looked at an apple and then thought it was a tomato for some reason, right? Because they are, maybe similar. So what happens is you say it's a tomato, and then the person that presented you with this question goes, yeah, I understand why you probably thought it was a tomato because it's red and round, but it's not a tomato, it's an apple. And then you perceive that information, and then it goes back to your brain, and then your brain now begins to understand that it's not important to know just the color and the shape of it. Maybe the texture of it is also quite important. So what you noticed, a pattern over here, is that something happens in the forward pass, which is where your brain processes these inputs, and then it makes a prediction of the output, which is an apple or not an apple, and then there's error that gets calculated over here, and that is being processed back through our brain, and then our brain tries to make a few fixes to come back with the correct guess over here. So that's the high level overview of what happens over here. To highlight some of the components of an artificial neural network is, it comprises of several neurons. So each of these circles over here is a neuron in itself, and they form a layer. How they form a layer is you have, and you get to decide how many layers you'd want. So in this image, there are two layers, and then you also get to decide how many neurons you want within each of these layers. So what they take is they take the inputs that's passed through the algorithm, and they process it. The details of what gets processed here would be discussed in another video, but for the sake of this video, we're just going to leave that as a black box, and then know that that output is further passed along to another neuron to make the final guesses. So in this example, let's assume that you have a table with three characters for the apple, which could be its size, its shape, its color, right? And then you're going that maybe I thought that the size. So the first x1, x2, x3 corresponds to the first row in the data set, and then your model will be trained for all the data in this data sets subsequently. So then you probably begin by saying the size of the tomato is probably 20% important, and then the shape is probably 40% important, and then the color is probably 40% important, and then it's being taken. So these are called the weights over here, which is W1, W2, and W3, and then it's being processed internally within each of the neurons, which also subsequently has weights assigned in the next layer, and so on. And let's say that it came back with a prediction that was wrong, right? So it probably thought it was not an apple. And then there is, so let me just visually show you. So here's where the weights get assigned. Here's where the neurons actually processes it, and then it comes back with an error correction. And in the backward pass, this error is being calculated, and that's what is very commonly called as a gradient descent. And I'll be covering the internals of what a gradient descent is in another video, because it's outside of the scope of this video. So that's what typically happens. So in the backward pass, a gradient descent is applied, which basically tells you that the parameters that are learned, how much should these parameters be adjusted. So then maybe you come back and you compute, and you're like, okay, because I probably assigned a weight that's too less for the size of the tomato, so let me bump this up by 3, by 1, so it'd be 0.3, and maybe you realize that the shape is probably not that important, so you just bump this down by another by 1. So then again the algorithm makes a forward pass to make a guess, and then it tries to compute if there is error that occurs this time in the guessing that it makes. So, and then you've done this for one training set, and then one entry from the training set, the second entry comes in, the third entry comes in. So within this process that repetitively happens, you settle down with the final values for these weights at each of these layers, which lets you make predictions on data that the algorithm hasn't seen in the past. So let me finish the backward pass. That was how an artificial neural network works.
So that was an introduction to artificial neural network. So where does convolutional neural network fit in? So here's where we talk about computer vision as a branch to computer science, that enables computers to recognize the visual world, right? So there are several machine learning and deep learning algorithms. In this tutorial, we're going to be seeing about convolutional neural network. So it's an extension to artificial neural network, as you see in this diagram over here. So it falls under supervised learning, right? Here's where CNNs are. It falls under supervised learning. So here's the realm of what we're going to be exploring. Yeah, so let's get going. This would be my last, section over here. So in here, what's essential for us to know is that there are several steps that goes into understanding how a CNN works. Maybe I'm going to start from the right end. So what you see is there's a lot of things that happens within, your scope of what a CNN would do. But essentially, uh, what you're trying to do is a lot of pre-processing to your image to make it compatible with your ANN, which is your artificial neural network. So this is essentially what we described in the previous cell over here. Is you're giving it a set of input, and there are one or more layers over here that takes your inputs, processes it, tries to make a prediction, and then eventually it would come back and do some error correction, and then there'd be a backward propagation that would go along, and then there'd be some correction again on the way. So this would be a pretty cyclic process that would happen. So right now, if these words like, image channels and convolution, pooling and flattening is not making a lot of sense, it shouldn't. And over the next set of videos, we're going to, take a deeper dive into each of these steps. And finally, we will revisit this diagram, and then you'll start to observe that it starts making a lot of sense. So that said, just one last note. So for this entire 8-part series that I just spoke to you about, we are going to be taking apples as an example. So we're going to work with an image that's an apple, and then we're going to try to predict if the image is an apple or not an apple. So that's it. Thanks for watching. See you in the next part.